So, hello everyone. Today we're gonna see how to print a simple hello world in assembler. In this case, in NASM, the net-wide assembler. So, to start with, we're gonna set up our environment. I'm working on a WSL instance. It's a Debian machine, and we're gonna set up our NASM environment, and also we're gonna see how to compile it, link it, how to assemble it, how to link it. And we're also gonna see how to use syscall in this case to print our string. So let's start with setting NASM. So to set up NASM, in my case in Debian, I'm using the package manager apt, so I just need to do sudo apt-get install and NASM. And I already have the latest version of NASM. So let's create a directory. Let's call it ASM learning. Let's cd to that directory. Now let's create a file called helloworld.esm because the extension .esm is for assembly. So I'm using NVim. So let's see, helloworld.esm. Okay. So to create a simply program, we need to start with defining an entry point for the program. An entry point is where the program will start to execute the instructions. So we will start by defining an entry point, and in Linux, the entry point is start. So, okay. So now we have our entry point. So global start. So now when we will assemble our program and when we will link it, the instruction will start to execute after the start. And so this is our entry point basically. So now we need to create the section. So we create section.text. Section.text is where our instruction will be, and we will start by defining the start. Okay. So now we have our global start is where our program will start, and the section text is where we will write our instructions. Now we need to see how we can to print this string. First of all, we need to see what we call a syscall. A syscall is basically we call a function from the kernel. In our case, we are working in Linux, so we can see the Linux syscall table. So if we go over here, the syscall table, we are interested in syswrite because this is used for printing to the console, to the terminal. So to call syswrite, we need to put the value 1 in the register area X, and we have other arguments. So let's start with doing the first thing. So to put the value 1 in a given register, we can use the operand move. So we move into area X 1. So this is called for write. Okay. Now we need to provide arguments. So to provide those arguments, we need to put into RDI the file handle. The file handle, if I recall correctly, one is for the stdout. Stdout is to output into the terminal. So we move into RDI the value. This is the FD, the file definition. So in RCI we need the character buffer. It's the string that we need to print. In RCI we need the file buffer. So to do this, we need to create a section called data. This section will have all the data that we can use in our instructions. For example, I need to create a string to output. So I'll create a string and I will name it message, MSG. So for short for message. It will be a DB. Okay. And I can just write hello world followed by 10. 10 it's the return line to return the line. So let's see now. And now we need to move this message into RSI. We move into RSI value of message. Okay. Now at last we need to move into RDX the size t count. The size t count is the length of the text that we need to output in bytes. So in our case, hello world is 12 bytes. We just need to count the characters and we will have the number of bytes, or we just can come here and write hello world and it's 12 bytes. But we need to add another byte because we have the return line. So we need to allow 13 byte. So again, let's check. So we have instance right. We need to put in RDX the count. So we move into RDX 13 bytes, and finally we can syscall. Okay, so basically our program is done. So we can go ahead and start assemble it and link it. So I save, and now I call the command NASM, and I output the file as felf 64 bit and hello world.esm. Okay, now I have an object file, hello world.o. If I check this object file, we will have an elf 64. Yes, it's an elf 64 bit. So we cannot execute this file. We need to link it. To link it, we need to call a command called ld. So we can just do ld hello world.o, and now we have a file called a.out. If we check the a.out, it will be an elf 64 bit executable, and if we execute a.out, we will have hello world, and also a very nice segmentation fault. Why do we have this segmentation fault? Let's open our program again. Okay, so over here we have the entry point, we have the data, we syscall for to print the data, but this is it. The program doesn't know what to do afterward, so it throws the segmentation fault. We need to give it something that we call an exit point. We need to give it the instruction to exit. The instruction to exit actually it's in the syscall table too. If I am not mistaken, it's in 60. Yes, it's in 60. So in 60, and we only have one argument, is the error code. The error code is the exit value. So we need to put the exit value in RDI. Okay, so let's implement it. So we move to RDX 60. We move to RDI value 1, it's the exit code, and we syscall. So this is the exit. Okay, now let's assemble it again. Hello world.esm. Let's link it again. Hello world.object, and let's print. And now we have our hello world without any segmentation fault. So basically we just saw a simple example to do a print in assembly. Next video I will show you how to do basic arithmetic, and I will go more in detail to explain the registers, etc.